Now take units of force. Units of force, actually these are called absolute unit. First one is Newton, this is SI unit. You know it, F is equal to m into A. If you are writing m is 1 kg and acceleration is 1 meter per second square, this is called 1 Newton. So actually 1 Newton is that force which can produce acceleration of 1 meter per second square in the body of mass 1 kg. So this is F is equal to 1 Newton. If you are measuring everything in the CGS system, suppose if you are writing mass is in grams and acceleration is in centimeter per second square, this can be written 1 dyne. So this is the CGS unit. When you take these two quantities and their relation, you can write here 1 Newton is equal to 10 raised to power 5 dyne. So these are the two absolute unit of force. There are some gravitational units of force, like you can take kg weight. 1 kg weight is equal to, we can write here 1 kg weight is equal to 9.8 Newton. This is actually here the gravitational unit of force. Now next topic here we can take here impulse. You might be knowing certain examples like in cricket, when bowlers throw the ball and batsman hit it. When the batsman hits the ball, the bat and ball come in contact for a short interval of time. So force applied by the batsman on the ball is for the very small interval of time, because of that direction of the ball changes. So the force which acts on the body for a very short interval of time, that is known as impulsive force. Suppose force F is applied on a body for a small interval of time delta t, then impulse is defined as F into delta t. Here we can take F average, this is a constant force we are applying for the time. So impulse is a vector quantity, its direction is in the direction of the force only. So this F average, which is a constant force applied for the small interval of time delta t, that is known as impulsive force, and product of the impulsive force and time interval is known as impulse. You can see in that way also F is equal to, we know it here, dp upon dt, rate of change of momentum. We can write this F into dt is equal to dp. Suppose you integrate it here, F dt is equal to dp p1 to p2, and here we can take time 0 to t. Suppose F average is a constant force, so we can write after integration here, we can write F average into t is equal to, here we can write p2 minus p1. That means impulse is equal to, this is impulse is equal to change in the linear momentum. So we can also say impulse is equal to change in linear momentum. Suppose we take graph over here like this. Here this side I have taken time and this side I am taking a force. If you apply larger force like F1 for time interval t1, and you can apply here F2 for time interval t2. So actually we can produce same change in linear momentum by applying larger force for small interval of time. So we can write F1 into T1 is equal to F2 into T2. So we are producing same change in momentum by applying larger force for small interval of time and by applying smaller force for the large interval of time. This is known as, sometimes we call it, or this thing is known as impulse momentum theorem.